Okay, welcome to the Zoom video for February 23rd. This week we're covering the chapter 4, which talks about loops. Loops are an important language construct in Python and most other languages, and allows us to perform actions that are repetitive, that we have to do things over and over again. So a loop allows us to avoid writing perhaps the same bit of code many times. Instead, it can be put into a loop and executed as many times as we desire. So like I normally do on Tuesdays, I'm going to go over my notes, which will give you most of what you need to know to do the programming assignment at the end of the chapter, and serves as basically a good overview of the concepts. So to start with, there are a couple types of loops that are used in Python and most other languages. They bear a similarity. The while loop in particular bears a similarity to the if-then-else constructs that we discussed last week. So a while loop is a section of code that will be executed as long as some condition is true. So similar to an if-then-else statement, we have conditions which work just the same as if-then-else statements. And there are a set of statements that get executed if the condition is true. So the main difference is that at the end of a loop, we go back to the beginning of the loop to determine if we're going to go through the loop again. So here's a bit of pseudocode. So again, this isn't Python. This is just sort of English statements that show how while loops work. So we have the keyword while, and we have a condition, and the loop keyword. Remember, this is pseudocode. This isn't Python. And then a set of statements, and then the end loop. So what happens is that at the start of the loop, we check the condition. If the condition evaluates to true, we execute the statements. At the end of the loop, we go back to the beginning. Once again, we evaluate the condition. If it's true, we execute the statements. If it's false, we stop the execution of the loop and continue. So here's a more concrete example. And this is a loop that has a bit of an unusual case because we're stating that the condition is always true. So while true, we do the loop. So you may be wondering how we exit this loop. Well, there's a special construct in Python called the break keyword or break statement, and that will exit the loop immediately. So in this type of loop, we set it up to continue basically forever. Okay, while true, since we have the keyword true, that means we don't exit because of the condition. Instead, we have an if statement somewhere in the loop that allows us to exit. So when we evaluate the if statement, we check the condition, and if the condition is true, then we execute the break statement, and then the loop exits. The break statement may occur anywhere in the body of the loop, and there may be multiple break statements. But in this type of a loop, we need to have a break or the loop will never exit. Okay. So let's get to an actual Python example. So in Python, again, it's pretty similar, but like if-then-else statements, we have a colon at the end of the main statement, which is while condition, then colon, and then we have statements which must be indented, just like the if-then-else statement. And then at the end of the loop, we continue on with our program. So here's an example, and we're setting a variable x to 3, And we say, well, x is less than or equal to 7, which is the condition. We perform these statements. Okay, there's two statements. Print x, which I see I've got a syntax problem here. There should be parentheses around the x. So I will fix that after the video. We print the x, and then we set x to equal x plus 1. So what's going to happen in this piece of code? Well, what's going to happen is we evaluate the condition. So while 3 is less than 7, which it is, we enter the loop, we print the value of x, which is 3, we increment x, and we go back. So now x is equal to 4. So is 4 less than or equal to 7? Yes, it is. We do the statements in the loop, we print, we increment x, and so forth. It finally ends when x is equal to 8. So when x is equal to 8, the statement 8 less than or equal to 7 is false. So we do not do the statements within the loop, and we continue on. So the output is going to be 3, 4, 5, 6, 7. Okay. Here's another example of the loop. This one has the style where the loop is always true according to the condition. So while true, colon, and then indented statements. And in this piece of code, if x to the power of 2 is greater than 100, we break, which means that we exit the loop. Okay. An infinite loop is something to be aware of, and it's perhaps you've seen this coming, but it's the style where we have while true, so the condition will never change. Okay, so while true, we perform statements, and if we never hit a break statement, the loop will never exit. So for this example here, we set x to 1, and then we enter the body of the loop because the condition is true. If x equals 0, we break. Well, x will never equal 0 because it starts at 1 and then it increments. So it goes from 1 to 2 to 3, etc. So it'll just keep counting up. It will never equal 0. So this condition, if x equals 0, will never be true, will never break, and it'll go forever. So this will probably happen to you at some point. Your program will just never end, and it'll seem like it's not doing anything or something's wrong. And what it means is that it's in what's called an infinite loop because it's infinite, it never ends. So generally, at least on Windows, you hit Control-C usually, and that will break out of it. Worst case scenario, you could exit the interpreter, you could exit idle, you could exit PyCharm, and that would also work on Mac. I'm not sure what the command on Mac is to break out of an infinite loop, but it's probably it's a certain key combination that perhaps you've used before. Okay, that's the first type of loop, a while loop. The second type of loop is called a for loop. Now, a for loop is different than a while loop because a while loop is based on a condition, whereas a for loop is designed to execute a specific number of times. Okay, generally in a for loop, we have a counting variable, which is just a variable that increments or decrements each time through the loop. And when that variable hits a certain value, then we'll exit. Okay, so this is a very useful type of loop when we know the number of things that we have. Okay, so we know the number of days of the week. We know the number of students in a class. We know how old someone is. So for each, we wanted to loop one time for each of these instances of the number. Okay, so the way that we do a for loop in Python, usually, okay, this is the most common style of it, although there's several. We have something called the range function, and we've used a few functions. Okay, we're not going to study functions formally till next week, but a function it's basically a keyword that you usually, not always, give a value to, or multiple values, and it usually returns a value. So we've studied the print function, we've studied the int function, the float function, the input function. Now we have a range function, and what the range function does is it returns. It's a special function that returns a value in a range each time we call it. Okay, so the format is for I, which is the variable name, which can be anything. It's traditionally or often it's I, J, or K. Okay, it's usually, but not always. It's really up to you what you name it. But that's pretty common for a counting variable to be I, J, or K. For I in the range 1 through 5, it's going to print the value of I. Okay, so what happens is each time through the loop, it's the variable I is set to a value between 1 and 5, not including 5, not including the last number in the range, which is a bit confusing. It's just something that you kind of have to learn and memorize. So I is going to be assigned the value 1, 2, 3, and 4 successively through the loop. Okay, so the first time through the loop, I will be 1, and it's going to print 1. Second time, 2, 3, and then 4, and then it exits. So what we're going to see in the printout is 1, 2, 3, and 4. All right. So I think having covered sort of the basics, I'm going to go in and do just some examples here. Okay, I'm going to create a new file. And I'm going to call it loops. And so first I'm going to do a while loop. So I will do an example of while, make a variable count set to 0. And I'm going to say while count is less than 10. And we're just going to print a count. It'll be very simple. Okay. And this is an important statement. I'm going to use the shortcut. Remember, we discussed that. We can say, instead of count equals count plus 1, we can say count plus equals 1. And then I'm going to run it. Remember, the first time through, we have to right-click on the name here and do the run command so that we can set up the configuration, which we need to run that. You can see down in the lower left here, it prints the values from 0 to 9, which is what we would expect. Okay. Now, if we don't have this line, okay, I'm not going to actually, if we comment that out, I'm actually not going to run this because it's going to create an infinite loop, like we discussed. So we print count, and then if we don't have this statement, the value of count will never change, and so the condition will never equal false. Since count is always 0, it's always going to be less than 10, and so this loop will never end. And by the way, we don't need parentheses around the condition. Some people use that style, some people don't. It's really up to you. It doesn't matter. Okay. So that's a very simple while loop. Here's another one, which we also discussed. So we'll say while true. We'll still keep the count variable. We'll print count. And we'll say if count is equal to 5, we'll break. Okay, and now we have to increment count. Otherwise, again, it won't end. Let's run this. And you can see it starts at 0 and prints up to 5, and then we exit. So at the end here, just to show that this does end, print a message done with loop. So we can see it prints the values from 0 to 5, and then the message done with loop. Okay, so those are while loops. So this is something that I haven't showed you yet. This is a way to comment out multiple lines at once. Okay, instead of using the hashtag symbol on each line, if we put 3 double quotes, okay, at the beginning and 3 double quotes at the end, then everything in between will actually not be executed. So that's a comment, and you can tell in PyCharm it has the color green. So it means that code will not be executed. So now we'll do some for loops. And we'll just do something simple here for I in range 0 to 10. Remember, it's actually going to be 0 to 9. We're going to print I, and we'll also print done with for loop. So something different about the for loop that I should mention is that we don't have to do anything with I. I is automatically incremented by 1 by Python, by the interpreter at the end of the loop. So that's, you can imagine there's a line at the end here that says I equals I plus 1. But we don't have to put that in there. That's automatically done by the interpreter, okay? So let's go ahead and execute this. And what we should see is it prints the numbers from 0 to 9, and then it prints the message done with loop. Okay, so basically just what we discussed in the notes. Okay, so this is just some examples of the range function. There's the style we've talked about, and the beginning and end values are arbitrary. Okay, so we can go from 1 to 5, actually 4, 3 to 6, actually 3 to 5, remembering that we have to subtract 1 from the last value. There's also a format of the range function where you'd put a single integer, and it goes from 0 to that number. Okay, so let's try this. Instead of 0 to 10, we'll just say 10, and it's actually going to print the same values. Okay, 0 to 9 like we had before. Okay, so there's a couple different ways to use the range function. Now, nested loops are where we put a loop inside of a loop, okay? And so we can do that. Let's just do that here. So we have a loop. So these statements can include other, any statements, right? So within a body of a loop, we can do another loop. So let's change this a bit so we don't have quite so much printed out. Let's make this 2. So we're going to go through this loop 2 times, right? From 0 to 1, and it's going to exit. And then I'll put in here another loop for j in range, let's say 3. Okay, so this is actually going to go through 3 times. We'll print j. Okay, I'm actually going to print, we'll add some spaces in front of j just to keep a track of the difference here. Okay, so let's go ahead and run this. So what happens is we print 0, then we print 0, 1, 2, and then 1, 0, 1, 2. So what's happening here, which is worth studying this a bit. Okay, so we have this outer loop. So I goes through the values of 0 and 1, and we print I, and then j goes through the values of 0 to 3, actually 2. We print it, and then we break out of this inner loop here. We go back to the beginning, and we set the value of I, but the value of j, since this loop since we've completed it the first time, it resets. Okay, so we're resetting this loop essentially. So j starts back to its original point, which is 0. So we go through this 3 times, each time through the outer loop. Okay, so we have the inner loop, the outer loop, which is for I in range 0 to 1. And we have the inner loop for j in range 0 to 2. And this loop, this value of j is reset each time we go through the loop. So it doesn't remember anything from, you know, the first time that we executed this inner loop. So that's important to understand. Okay. So a common thing that happens in a loop is we have something called an accumulator. Okay, the text mentions this, and that's just a way to keep track of the total value of something, and that's going to be something that you will commonly do in homework exercises and in almost any program. When you have a loop, you'll keep track of some value, okay, as you go through the loop. So here's an example where perhaps we're so this program eventually prints out the average age of a group of people. Okay, so we start out, we set a couple of variables, total age equal to 0 and count equal to 0. Okay, so count will be the number of people that we're gathering statistics for. Right? And the total age is the total age of all these people added together. And the way that we get out of this loop, this while loop, is we have a condition that says if age is greater than 0. Okay, so it wouldn't make sense to enter a value of 0 or less for an age. And in the body of the loop, we're going to keep track of the total age of all the people that were entered. Okay, so total age equals total age plus age, which is the value that's entered here in this input statement. We cast it to an integer, which makes sense because we generally don't think of a person's age as like 24.5, right? We just say the age in years and we round, we basically round down, okay? So we go through the loop, and as long as we don't enter a 0 or less, the loop will continue. We'll keep track of the total age, which again, this is an accumulator. It's a variable that keeps track of a total amount of something. In this case, it's the ages. The count is incremented each time. Okay, we need that to compute the average. And another very important thing is that at the end of one of these types of loops, we have to get the input again, because if we don't do that, the input is never going to change. So we have to change the input, which is age, somewhere in the loop, okay, usually at the end of the loop. And that's how we'll get a new value each time. And that's how we'll eventually exit the loop. Okay, so then we print the average, which is the total age, divided by the count. All right, so this kind of a loop is going to be very common, something that you will definitely do in a number of programming exercises. Okay, you have a loop, you initialize some variables inside the loop, you increment some value, or you add some value to an existing value, and then you exit the loop by a comparison on the input variable, okay, which is what you're getting from the user, in this case, age. Okay, so let's sort of, I won't do the whole thing, but let's do something, let's do part of that. Okay, so say age equals, cast it to an integer. Okay, age greater than 0. Okay, we need a separate variable to keep the total value. Okay. If we don't do that, then we're going to lose track of what the total age is. So we can't just say age equals age plus age, because then when we read the age again, we're going to lose the value of the total age. So we actually need two variables here. Okay, so we want to say total age equals, we'll do the shortcut age, and then we need to get the once again, if we don't repeat this line, then this loop isn't going to end because age won't change. Okay, so if age was, let's say 10, and if we don't reset that age in the body of the loop, it's never going to be. So it looks like I messed it. Okay, never mind. That's right. So if age is 10 and we don't reset it in the body of the loop, this loop will never end. Okay, because it's always going to be greater than 0. So essentially, we just cut and paste this line, and at the end, we'll print total age, and let's see how this works. So what is the age? Say 10, and it just keeps going through this loop until we make the age 0 or less. So if I put 0, then the loop will exit, and we'll print the total, which is 70. As you can see, 40, 60, 70, so that is correct. Right. All right. Another way that a loop can be exited with a while loop is that we have something that's called, in the book at least, a sentinel, which is a special value that causes the loop to exit. And this is another thing that you'll see in your homework problems frequently, is that, how do you exit the loop? Well, you enter a specific value. Okay, so in this case, the loop exits when the name, okay, so we're asking for a student name, which we're just getting a string, a set of characters, right? We're not casting it to an integer or float, just a string. So while the name is not equal to, okay, this is sort of a special notation here. 2 quotes together is an empty string, which there's nothing to print. Okay, there's no characters inside here. Okay, so if we have that, and you get that by just hitting the enter key. Okay, I'll show you in a second how that works. So if it's not an empty string, we go ahead, and this loop just gets the name again. Okay, it just loops until you enter an empty string. So let me show you how that one works. Okay. So we'll change this a bit. We'll say, what is the name? Okay. While, oops, name not equal. Okay, so just 2 quotation marks. We'll go ahead and print the name. And then so something to note here, that in PyCharm, this little squiggly line means that you have a mistake in your program. Okay, so if we look at this, what's the mistake? Well, the mistake is that we have 1 left parentheses and 2 right parentheses. So when you have parentheses in Python, you always need the same number on the left and on the right. Okay, so let's go ahead and try to run this and see what we get. And so what we get is a syntax error, and it actually points to the error here, and we have mismatched parentheses. So we have to get rid of that. You see the red line goes away. Okay. Now, if I were to run this, and if I don't enter a blank line or an empty string, okay, this is another thing it's going to execute forever, because we have to reset name so that when we get to the beginning of the loop, the condition will fail. Okay. And the easiest thing to do is just to cut and paste. Okay. So let's run this. What is the name? Ted. Prints Ted, goes back to the beginning of the loop, asks again, what is the name? Susan. This time I'm just going to hit the enter key. I'm not going to put any characters. And the loop exits, as you can see. Okay. So when the name does equal an empty string, and we'll get that by just hitting the enter key, then the loop, the condition is false, and we exit the loop. All right. So that's kind of a special type of string. That's a pretty common way to exit a loop or a program. All right, so just a bit more here. So we're not going to get too deeply into this. I think there's an example. Not sure if it's this week or another week, but when the user enters something, we can't be sure it's going to be what we want. Okay, so if we're expecting them to enter someone's age, right? So what we're assuming is an integer between 1 and 100 probably. But if they don't enter something like that, then we have a problem. Okay, so what if they enter these things for ages? Okay, -1 makes no sense. 200 makes no sense. Apple makes no sense. 33.333. I mean, technically that could be right, but probably not, because people rarely state their age in a fractional value. Okay, so that's probably wrong. And these inputs will cause our program to work incorrectly, or issue an error, or crash. Okay, and maybe you've heard of the statement garbage in, garbage out. It means that if the inputs of a program don't make sense, then you're not going to get valid outputs. And so we will learn this term or this semester how to handle that sort of thing. Basically, what you do is you can test that the input makes sense. Okay, meaning it's a realistic input. And if not, you give a message to the user that says, hey, this number or this input isn't valid. Please enter something valid. And you've probably seen this. Maybe you filling out a web form and you accidentally put your name in the part of the form that's asking for your phone number, or vice versa, and it tells you that you made a mistake, and you go back and you fix it. So that's basically what we're talking about here. And we will talk about that a little bit this term. And just to give you an example of what that looks like, okay. So similar thing, we're computing that we saw before, computing the average age of a person. Okay, so we set up our variables, the accumulator, total age, the count of the number of people that we've entered, and we have a for loop, and we ask the user to enter the age of the person. And this is where we're doing some validation. So we're saying, well, age is less than 0. We're setting up a loop here. Well, age is less than 0 or age greater than 100. We're going to print out an error message that says age should be 0 to 100. And we give them another chance here. So we're repeating this line here. What is the age? Okay, so as long as they print a bad age, we're going to be stuck in this loop and we're just going to keep asking the user to enter a valid age, which is 0 to 100. Okay. Now this example is only checking for one type of problem, which is an age that's outside of the boundaries. Okay, what if they enter a non-integer value? Okay, well, what's going to happen probably, most likely, is that we're going to get an exception and the program is just going to crash. Okay, but we haven't learned about exceptions yet, so we're just going to set that to the side. Okay. We'll talk about one more thing, something called a flag. And a flag is a Boolean variable. It indicates that some condition has been met. Okay, so it means that something happened in the program, which means generally, we can exit the program, we can exit the loop, or some condition has been met that we can perform some set of statements in the code. So let's go through an example here that'll make this more clear, hopefully. Okay. So what we want to do in this little program is determine, tell the user if a negative value was input. Okay, so we have a loop, a for loop, and we're asking the user to input numbers each time through the loop. So this statement here, what is the value? So we're asking the user to enter an integer value. We're keeping track of the total of all those values. But there's a special case here. If the value is less than 0, in other words, if it's negative, we're going to set something called a flag, which is a Boolean variable. And we're going to name it has negative, okay, which means if has negative is true, then the user has entered a negative value. Otherwise, it's going to be false because we've initialized it here. Okay. So we go through this loop. It's a for loop, so we're going to go through in range of 5, so it's going to go through 5 times. Okay. And it's going to automatically exit. We don't have to do anything to make this for loop exit. And at the end, we're going to print the total value, and we're going to tell the user if there was a negative value somewhere in that input. Okay, for some reason, the requirements of this program are that we want to make sure that the user knows there was a negative value, and so that's how we keep track of it. We have this special variable called a flag, which is usually a Boolean variable. It wouldn't necessarily have to be, but it often is. And that tells us if there was a negative value. Okay. So why don't we go ahead and do that? Okay, just to show you, we don't have to always use y. We can say for value in range 4, we'll assume you're entering names again. Okay, so name equals input. That. If name is equal to, let's see, Stephen, we'll create a flag variable called, we'll make it a long name. Do we have a Stephen? Okay, we'll set it to false to begin with. So if we never enter the value Stephen, or if the user never enters that, then this code, the statement will never be executed. Okay, which means this value will never change, which means we did not enter that name. Okay, so we're just going to print if, okay, so we can either do it this way, compare it to true, Or we can do it this way. Since it's already a Boolean variable, it already evaluates to something. Okay. Okay, so what this little program is going to do is if the user enters the name Stephen, it's just going to print that out at the end. Okay, let's just go through 2 times the loop, right? So what is the name? The name is Mark. The first name is Mark. The second name is June. It doesn't do anything because the user didn't enter Stephen, and so this never changed. So the value of this flag variable, this Boolean, is always false. Since it's false, the statement isn't executed, so we don't see that. All right, let's do this again. This time, I will type Stephen for the first name. For the second name, I'll type David. And now it does print this message because we did print the name Stephen. Okay. I will note one thing here, just since we're it's a good example of this, that in Python we have something called case sensitivity, which means Stephen with a capital S and Stephen with a lowercase s are 2 different things. Okay, so if we went through this and I type Stephen and then I type I'll type Marcus, we don't get this message. Even though we type Stephen with a small s instead of a capital S. So that makes a difference, and that's something that you will probably run into at some point where your program doesn't work right and you don't know why, but it's because we care about the case, whether uppercase or lowercase of a string, right? And we'll talk about how we can get around that, how we can make sure that we're always dealing with the right case. But for now, I think I will end the video. So please, if you have any questions, let me know. I can, on Thursday, we can go over more examples. I'll probably do an example or 2 from the end of the chapter of the problems. But if you have any other questions, let me know, and I can include that in the video as well. So thank you, and I will talk to you next time.